Yeah, we're
heat and pressure of a
Your call has been forwarded to an automatic voice message.
But because of the perseverance, here we are today. And it's these engineers and scientists and innovators that have poured their life's passion into this work, and it's now come to fruition. And it's progress like this that drives us forward, and it gives us inspiration. Our rockets run on fuel, but inspiration is the fuel that drives NASA, and indeed drives humanity. So this novel innovation that made Webb possible is exactly why NASA and why humanity continues to push the envelope, as the test pilots say. Push the edge of the envelope. NASA's no stranger to first steps, and as we enter this new era of spaceflight and discovery, we need to be bold. We have to take risk, but the reward is worth the risk. And this is proof of that. It represents the largest international space science program. It collaborates internationally. Now, Michelle, I'm going to turn it back over to you to share messages from our international partners.
Thank you so much, Administrator. The mission would not be as successful as it is today without the teamwork and contributions from our mission partners, the European Space Agency and the Canadian Space Agency. We are pleased to share with you a special video message from ESA's Director General, Dr. Joseph Aschbacher, and their Director of Science, Gunther Hasinga.
The James Webb Space Telescope is such a fantastic opportunity. It's a once-in-a-lifetime opportunity which we have here, and we are so excited, both Günther and myself, on this first data release. It will really change the understanding of our universe. But before I hand over to Günther, just one word. This is also a symbol of international cooperation. The partnership we have with NASA is outstanding. It's really exciting, but really fantastic, and also with CSA, the Canadian Space Agency, and this is more than science, it's also a symbol of international partnership. But Günther.
because pride is powerful, but somebody's going to ask you a question, did you do it right? And somebody's going to look at a picture when you did it and see, was it right? And somebody else was going to review that and stamp that it was right. And every single person mattered in that. And in the end, it was perfect. So thank you. And working with Bill was really a relationship that's going to last a lifetime, over a decade. I think we broke the record for industry-government partnership. We're not supposed to be together for 10 years, but we were. Bill.
Thank you. Well, I guess I'm the cleanup, typical job for a project manager. First, just a little update on the observatory. Over the weekend, we finished the last commissioning activity, so we are officially done with commissioning. We have an observatory that is in excellent shape, that either meets or exceeds requirements. And as mentioned earlier, we have 20+ years of fuel on board. And finally, we have actually started our first
20 años de combustible. Gracias a Ariane Space. Hace un rato presentaron. Voy a bajar el volumen de ellos. Hace unos minutos estuvo la gente de ESA, le dieron el reconocimiento a la Agencia Canadiense también, lo cual fue espectacular. Algo que no hizo el presidente Joe Biden ayer, el presidente de los Estados Unidos, cuando presentó la imagen. Parecía que fue América, como dicen ellos, o sea, los Estados Unidos de América, quien hizo todo esto. Y ahora, la verdad está espectacular, los agradecimientos que están diciendo toda la gente involucrada y a toda la ciencia.
We would not be successful without your contributions to the Webb program. When I see these images, I see four things. I see dedication, and I have never seen dedication on this project like I have seen on any other mission I have worked. I see personal sacrifice of so many individuals that my heart is just overwhelmed with pride for the folks on this program. Finally, also I see passion. I've never seen the passion for this program. That's what helps with the first two things I mentioned. Finally, I just see the faces of all our individuals who have worked on this program, both the past and the present. And neither myself nor NASA will ever be able to thank these persons enough.
Your call has been
finally,
forwarded to an automatic.
Personal note, the Webb team itself, we are all going to be bonded for the rest of our lives by the Webb experience. And I have to thank you for the privilege that you have allowed me to be part of that experience. Thank you.
Thanks. All right. Thank you and congratulations, gentlemen. And congratulations to all of you once again. Today, we celebrate you and your achievements. Now, listen, I'm sure you're excited to see exactly what Webb will show us. So here's the plan. We're going to take a quick break, but as you all at home can see the countdown clock, we're literally minutes away from the reveal. Are you all still excited? It has been my absolute pleasure spending this time with you. We can't wait to share what humankind is capable of, and we are just getting started. Let's enjoy this journey. Now, on the count of 3, I want you all to scream, "Go Webb." 1, 2, 3. Go Webb!
Y voy a hablar un poquito sobre esto. Quiero mostrarles algo. Ayer compartí en Twitter. Voy a buscar Twitter. Estoy buscando en Twitter lo que publiqué ayer, así ya les pongo exacto. Les voy a mostrar la página. Uy, sí, ¿por qué no sale? Cambiaron la página, yo no puedo creer. Estoy cambiándola, estoy poniéndola sobre un poquito de música. Sí, les muestro. A ver si... Tenemos acá. Y acá tienen para descargarla. Esta es la página que les había puesto. Se ve que la cambiaron el sitio. Y para atrás. Ustedes entran acá. Voy a copiar para colocarlo en el chat. Es re interesante que puedan acceder a la imagen de máxima resolución. Estoy poniéndolo, lo acabo de poner en el chat. Digo por qué. Es impresionante. Una cosa es lo que vimos ayer, que nos mostró el presidente de los Estados Unidos. Esto está bárbaro. Y uno ve acá la forma de las galaxias, que ahí parece una espiral. Onda, España puso también algo que estuvo muy bueno en su sitio. Pero cuando empezamos a agrandar, se ve algo que ayer no nos mostraron. Miren qué increíble esto. Qué increíble. Y hay gente que decía, tanto para esto, tanto en el chat, ¿no? ¿Cómo puede ser que hagan tanto ruido con esto? Una galaxia. Esto que se ve así es por el efecto de lo que es el lente gravitacional. Las galaxias que están acá desvían la luz y hace que fuera como una lupa. ¿Ven lo que pasa cuando ponemos una lupa al sol que concentra los rayos? Bueno, hace exactamente eso. Por eso se ven todas así, como giradas. En realidad esto es un lente gravitacional. Miren esto. Dale, brutal. Hay algo más también, acá hay otra. Y son miles. Y esto es un grano de arena estirado así, puesto en el cielo con todo el universo. Yo no me imagino lo que vamos a poder ver en el James Webb. Qué brutal esto.
This very special day.
How are you feeling?
I am thrilled and I'm relieved because you know when you start something this big, you know there's always a possibility it might not work. It did work. We are so proud.
Este es el científico, este es el uno, este es el número uno
Started in
del proyecto.
1995. We had just finished measuring the Big Bang. We measured it with the Cosmic Background Explorer satellite that we built right here at Goddard. And we measured the spectrum. We measured
En los 90 pudimos medir la expansión del Big Bang,
how
dice.
it all got started. But then what happened after that?
Pudimos verlo ahora. ¿Qué pasó de eso?
Reporters, would I like to work on this new telescope that's going to help
Dice, entonces
answer
ahí
those questions?
me llamaron
What
de
happened
NASA
after the Big Bang? How
y
did
se
the
tenía que
galaxies
trabajar en
grow?
algo de
How did the
esto.
first black holes grow? What happened all the way from there to here? So this is our time machine, and I just wanted to be part of it. I am so thrilled that we got a chance to do
Y esto es
it.
una máquina del tiempo. Y de verdad quiero tener la chance.
You thought that this mission was the most important thing to work on.
Absolutely. It's the next question. After you know how it started, what happened then? And, you know, suddenly we now have the technology to do it. We didn't have 50 years ago. We didn't have the technology 25 years ago, even when we started this.
Tenemos la tecnología. No la teníamos hace 20 años cuando empezamos con esto.
So at the moment, we're going to talk about the way that Webb is a completely new way to explore the universe. So today, the mission releases its first science images and gives wings to the dreams of so many people who worked so hard for so long to make this possible. For everyone on Earth, this is your telescope. This is the largest, most powerful observatory ever put into space. It's the product of thousands of people working for more than 2 decades. This is a
De miles de personas trabajando más de 20 años, 2 décadas.
The following phrase is often used too easily, but today actually
Han sacado a Marco recién, justo.
Today the Webb mission is
Lo
open
que pasa es que
to
estoy
business.
nada,
And this is just
4 manos.
the best is yet to come.
¿Quieres entrar?
So, John, one of the things you told me about is that you really want to make sure there are some people that get thanked, people that put a huge amount of effort into this.
Absolutely. Our current project manager, Bill Oakes, took the project from a time of trouble when we didn't exactly know how we were going to get this to work, and got it all the way to the end. Here it is working, and it's because of Bill made this worldwide team. 20,000 people around the world were involved in making this thing all work, and Bill has been there every day making sure that it would happen. So other special person is Senator Barbara Mikulski. She saved our telescope, and she saved the telescope before us. She made sure after the Hubble telescope was launched and it was not in focus that we would go up and fix it. She made sure that happened. When the Webb telescope needed more resources, she made sure we could get that. So, Barbara, we thank you.
Well, it is such an honor to be with you, Jay. I mean, it's been a pleasure to be working with you through this whole thing. Thank you so much. Congratulations, and go Webb.
Thank you.
So this broadcast, much like every part of this mission, is a partnership. On our journey to explore distant places in space, we've been joined by intrepid travelers from around the globe. We have so many extraordinary
Y me
collaborators.
dice,
So let's check in with our
se
partners
he compartido
on stage with us today as we review
y está saludando
the first science images. From the European Space
en la
Agency,
Agencia Europea.
Katie Haswell in
Qué
Darmstadt,
buenísimo,
Germany.
buenísimo.
Katie. I see Katie in the background there. Also joining us from the Canadian Space Agency in Montreal, we have Natalie Willette and Sarah Gallagher. Bonjour.
Salvando ahora a la Gallagher de la Agencia Canadiense.
Background there. See the waving too. And so naturally, we're also going to be visiting the nerve center of this mission, the Space Telescope Science Institute on the
Bueno,
campus
se
of
ve que
Johns Hopkins
no
University.
tuvieron enlace de audio.
And there we have Alex Lockwood and Carl Gordon, and they're going to give us updates.
Si subo mucho el volumen, no me escuchan a mí.
Great. So we'll be back with our international partners shortly, where they'll each reveal one of the new images. But today we're also going to be joined by millions of science fans from around the world. Many are gathered at watch parties just for this event. So here we are really going international. So I'm beginning with Bhopal, India. Do we have a signal from Bhopal? Yes.
India también,
Excellent.
otros
Welcome to
socios.
NASA. Hello, everybody
A la
there.
gente de India.
Wonderful to be talking to you today, all the way in India. We'll be back to them later, yes? Great to wave to you. Hi, wonderful. And we also have a warm welcome now in Portland, Oregon. So we have the feed from Portland. A bit dark, but I see everybody there. Hello, Portland. They're in an auditorium, I see. Okay, next we're going to go off to Milan, Italy. So afternoon in Italy. Do we have the feed from Italy? I guess we have a screen from Italy. And next we're going to go to Rutland, Vermont. So is this Vermont? Hello, Vermont. Hi, everybody. Nice to see you. Thank you for being part of this today. Okay, going even a little bit further afield, we have Netanya, Israel. Hello. Hello, Israel. Yay. Really nice to see you guys. Okay, and just one more for now. I see people like giving me hugs. Okay, we also have Vancouver, Canada. Hey, Vancouver. Hi. All right. Wonderful. Wonderful to have all these people with you. So right across from the campus from me, there's also a huge watch party taking place with members of the Webb team. So the wonderful thing is that they actually are people that have worked on the mission, and they are part of our NASA Funny family. So hello. Hello, Webb team.
Your call has been forwarded
There they
to
are. Yes. A lot of people I recognize there. So it's incredibly important to me personally, and also to all of us at NASA, that the universe belongs to everyone. And we are thrilled to share this day with fans everywhere around the world. We'll say hello to some more later in our broadcast. So now it's time to start the main event. What you'll see over the next hour will be a collection of images newly processed by the Webb science team. Only a tiny handful of experts have seen the images so far, and I can tell you that we have been so excited to unwrap them for everyone. We will be releasing each image in turn in real time. As soon as you see it on this broadcast, it will be available for download on the internet. On the screen below, you can see a timeline showing where we are in the show and what's coming up next. And by the end of the show, all 5 images will be available to everyone. So hopefully you can tell I'm excited. Okay, so let's do this.
Hicieron un copyright por lo del presidente, increíble. Tenían música con copyright.
We released the first image right here at NASA Goddard Space Flight Center, Maryland, and we're just outside of Washington, D.C. NASA Goddard is home to the project office of the Webb telescope, and the observatory portion of the telescope, the mirrors and the science instruments, were integrated and tested here before launch. So for many of us, including myself, seeing Webb come together bit by bit right in front of our eyes was an emotional and very inspiring experience. So it's kind of like a part of us was out there with Webb right now. A million miles away, part of our hopes and dreams are out there. So I'm joined now by Jane Rigby, the operations project scientist for the Webb mission. And she's a familiar face for people who've been following this before, so welcome, Jane.
Hi, Michelle.
Okay, so Jane, you not only get the honor of revealing the first image, but this actually got a little bit of a sneak preview. I understand there was a very select audience who already seen the image.
Yes, so last night, on behalf of the project, I had the privilege of traveling to the White House with the NASA Administrator Nelson and other senior staff to share our first image with President Biden and Vice President Harris. And it was really fun. Oh my gosh. They really geeked out. We had a closed-door session where we got to walk through all the images and just share the excitement, and they were so thrilled, and they got the profundity of what we're seeing. And so now we're gonna let's do it.
Okay, we've got the whole world watching. Are you ready to put the first image up?
Oh, let's do it. Let's do it.
Absolutely. All right, here we go.
Okay, so the first image is a deep field, and it's also a deep field with a cluster. So why don't we walk through this just a little bit? So if we come up and look at this image, first of all, it's really gorgeous, and it's teeming with galaxies. And that's something that has been true for every image we've gotten with Webb. We can't take blank sky. Everywhere we look, there's galaxies everywhere. And so, you know, this image, as we're looking at it, what we're seeing is not just all the galaxies, but there's a cluster here. And so the cluster are all these white, kind of ethereal galaxies. We're seeing them as they looked back in time, right? The speed of light is only so fast. And so as we're seeing distant galaxies out in space, we're seeing them as they looked billions of years ago. So these cluster galaxies, the white ones, we're seeing as they looked about the time the sun and the earth formed. And then behind the cluster, we have the gravity of the cluster is distorting and warping our view of what's behind. And so there are these galaxies that look stretched and pulled, kind of like they've been magnified because they've been magnified by the gravity of the cluster, just like Einstein said. And, you know, it's really, there's so much detail here. We're seeing these galaxies in a way that we've never been able to see before. There's just a sharpness and a clarity we've never had. And so we can look at, if we zoom in on this image, and I encourage you as you grab this image at home, like zoom in. You can, you know, really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars forming, popping up just like popcorn. And then we also see in the background of this image kind of littered like jewels all
Los
over
de
the back of
luces,
the image are these
luces.
faint red galaxies. Now, that was what we built the telescope to do. The most distant of those are billions of years. We're seeing as they looked more than 13 billion
Lo
years
último
ago.
que se ve ahí, lo
And
más
so
distante, son
galaxies like
de
that
13
one right there,
mil
this little
millones de
red guy,
años.
you're like, okay,
Acá vemos algo rojo.
what is that? Well, Webb got spectra to figure out what those galaxies are made of, and this is that one.
Y ahí
We're
tenemos
seeing
lo
as
del
they look
espectrógrafo.
13.1 billion years
Este
in the
instrumento
past,
NIR
less
lo
than
hizo
a
Lockheed
billion years after
Martin,
the Big Bang. And we're seeing the elements of
uno
oxygen
de los socios
and hydrogen.
de United
well,
Launch
xenon.
Alliance.
You know, this is how the oxygen in our bodies was made in stars, in
Esto es lo
galaxies.
más
and we're
lejos
seeing that
que
process
hemos
get
conseguido ver ahora.
I want to give this a little bit of context. So this is now the farthest away galaxy that we have this sort of detailed information about.
That we know what it's made.
We know what
Y
it's made
tenemos
of.
todos
And this
estos
is not long
detalles
exposure
que vienen de la luz
Now,
de esa galaxia distante.
The previous record holder, right, the Hubble Extreme Deep Field, was 2 weeks of continuous work with Hubble, and it was just imaging. With Webb,
El procesamiento de esto
before breakfast.
de
The
Hubble
amazing thing about Webb is
le
the
lleva
speed at
2
which we can
semanas.
churn out discoveries. So everything that
Y
you're
acá
gonna
con
see
esto lo
here
hicieron en
this
horas.
podcast is a week, and we're going to be doing
No.
discoveries like this every week.
Dice una semana, dijo ahora.
Thank you so much
Dice,
for
vamos a
joining
hacer
us.
descubrimientos de
It's an honor to
estos
be working with you.
todas las
Congratulations
semanas.
on all your hard work.
Thank you. It's so wonderful to see it pay off.
Dice,
Thank you, and I'll see
buenísimo
you
ver
later on today, I hope.
que esta es la
So
paga.
enjoy the day. Thank you. Right. So from distant galaxies, we now turn our eye to something a bit closer. It's a planet, but not one in our solar
Me
system.
desespera, me
Remember that Earth and
desespera.
its sibling planets aren't the only show in the universe. When scientists and engineers
Qué
started
vuelta que
developing
dan, no puedo creerlo.
JWST, the search for exoplanets wasn't even part of the plan. That's changed. Exploring exoplanets is now a major component of the mission.
Vea, va a hablar de
and
los
it's subject to our second
exoplanetas
big reveal today. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space
Sarah
Agency in
Gallagher.
Montreal.
Oh,
So again,
Montreal.
bonjour.
Esta es la paga, me parece. Esta es la paga, me parece. Que Montreal anunció, o sea, Canadá. A ver. La paga de que ayer habló el presidente, ¿no? Que esto no somos nosotros, ¿eh? Yo tengo internet.
She's an exoplanet scientist at NASA, and we're going to talk about this amazing new result from a very hot planet, I understand about 1,000 light years away.
That's right. The exoplanet is named
Sobre este planeta que está a miles de años.
and it is this hot, gaseous, giant, puffy planet.
Es un
but it
gigante
is
de
about 1,000
gases.
light years away. So that's why today's release is so exciting because it teases at what Webb is able to do for such a distance.
Absolutely. So talk us through what this discovery is and why this is so significant.
Well, this reveal that you're going to see is going to show the first spectrum of an exoplanet as taken from the Webb telescope. And this is exciting because it covers infrared wavelengths of light that we have not had access to before. So we've been able to use other telescopes to explore exoplanet atmospheres in the infrared, but not to this level of detail. And this is just one sliver of data that Webb is providing us using the nearest instrument specifically.
And there's something about infrared that is actually particularly good for the spectrum. So in this case, what we're doing is we're actually going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum.
Tomamos la luz y la abrimos, como si fuera un arco iris.
We're revealing the spectrum right here.
Este es el
So
espectro.
we now have our
O sea,
spectrum, and
justamente un
this is
espectrógrafo.
exactly what you're seeing, as you just described with spectroscopy. What we did
Una
was we observed
espectroscopía.
the transit of an exoplanet.
Y podemos
We
medir
observed
un
the planet
tránsito
as it passed in front of the star. Now, mind you, this
por
is not
delante
a
de su
direct
estrella.
image. This is an indirect image. So we've seen the
Esta
effects
es
of
una
what
misión
happens when the planet
indirecta.
passes in front of the starlight filters through the atmosphere, and then you can break that down into wavelengths of light, and you get a bunch of what looks like bumps and wiggles to some people, but it's actually full of information content.
Y en el momento
So
que
we're
cruza,
actually seeing
ahí tenemos
bumps
un
and wiggles
montón
that
de
indicate
información.
the presence of water vapor in the atmosphere of this
Y tuvimos la
exoplanet.
indicación de vapor de agua en la atmósfera.
Anything you'd like to highlight particularly?
Yeah, absolutely. So
Agua.
we have several features marked here. So I call them features. They're these, what I just referred to as bumps and wiggles. But what you're seeing here is a telltale signature, the chemical fingerprint of water vapor in these atmospheres, in the atmosphere of this specific exoplanet. And the other thing we can tell actually is that there's evidence of clouds and hazes because the water features are not quite as large as we predicted. So we can take that and infer that there are presence of clouds and hazes.
Right. Now, one thing that we really want to make sure people understand is with this particular planet, this is a hot world. It's actually closer to the star than Mercury is to our
Está muy
sun.
cerca al
So we're
Sol,
not
a su
looking at
estrella.
liquid water here, but we're looking instead at sort of steam, water vapor.
Yes, this is an exoplanet. It's about the size of Jupiter, about half
Es
the
el
size
doble
of
de Júpiter.
It orbits around a sun-like star, but it does it every about 3.5 days. So
3
extremely
días y
hot,
medio da la
looks
vuelta a su
nothing
estrella.
like our solar system planets, but that's okay because
Mira,
what we're
ese planeta.
seeing
Está
is
bien.
again the first exoplanet data from Webb, and this is just the beginning. We're going
Y
to
entonces
start
el
pushing down
principio
further,
dice, el primer
smaller
exoplaneta que
planets,
miramos.
and being able to take measurements just like
Vamos a
this
mirar
with the nearest
otros
instrument
y
that
y
was
ver
built
cosas
by the
como
Canadian
estas.
Space Agency, but also there's three other science instruments that will add to our knowledge in the infrared, as
Qué
well
loco,
as direct
qué
imaging
loco, qué
of
loco.
those, along with the transit method. So there's a lot more to come.
And I guess one thing we should mention is not only are we going to be looking at planets that are more like the Earth in the future, but we'll also be looking at planets in our own solar system.
Absolutely, yes. We're going to have exciting data from planets in our solar system, from Mars outward, as well as asteroids and comets. So stay tuned for a lot more to come.
Thank you so much, Nicole. Thank you so much for telling us about the spectrum, and I'll be seeing you later on today. So we have 3 more big image reveals, and with that, new and more exciting science. But first, let's take a look back at the journey that brought us to this moment. Celebrations like this one are only possible with years of hard work from a cast of thousands. When a new mission is being built, even the most enthusiastic space fans only get to see dramatic moments in its life cycle, the news and images that come out in updates and press releases. But that doesn't really give you the sense of the huge effort that goes on behind the scenes every day. The plans, schedules, and organization to keep everything moving forward really happens, for the most part, out of people's gaze. Webb started as an idea that took root at NASA Goddard. It grew first into planning teams, research projects, schematics, requirements. Then it began the long journey to become real with the development of new technologies, cutting-edge engineering, and finally fabrication, putting it all together. Let's take a brief look back at the visionary journey to how we all got here today.
So today was the final closeout of the purge.
Okay, guys, I can hear Rupa, but
It's a pretty emotional moment to be in there and actually, you know, closing it up for the very last time, right? You know, you're the last one to touch this, and so that was the final operation. And once that fitting is closed out, there's no more touching of the vehicle. We're ready for launch.
The James Webb Space Telescope, born from the desires of astronomers, achieved with newly invented technology, is the culmination of 20 years of work.
Se están dando todo con cuentagotas, ¿eh?
Has unlimited
Qué terrible.
questions about our universe. Engineering a way to investigate them requires enormous creativity.
Webb has been a trade-off between engineering performance, what the astronomers want, risk. In fact, when we started 20 years ago, we were actually looking at an 8-meter telescope.
Developing the most sensitive instruments, and testing, and more testing.
And so you don't want to build one that's just incrementally better than what you've got. Because if that's the case, you would just observe longer on the telescope that you already got. And so every time NASA builds a new astrophysics mission, a new telescope, it needs to be way more sensitive, you know, way more capable than anything we've ever built before.
We all got together in that conference room and we played real time as the images came down from the spacecraft. The very first diffraction limited images ever obtained with Webb. And what we collectively saw as a group was the highest resolution infrared image taken from space ever.
If you're just joining us, I'm Michelle Thaler at NASA's Goddard Space Flight Center, and you are watching live coverage of the release of the first science images from the James Webb Space Telescope. So it's appropriate now that I send the broadcast to our colleagues and friends at the Space Telescope Science Institute in Baltimore. That's the scientific nerd center of the entire Webb mission. So hello, good morning, Alex. The show is yours.
Hey, Michelle. Welcome to the Space Telescope Science Institute. I'm Alex Lockwood, and I'm here with Carl Gordon, who is an astronomer and one of the key people in delivering the images that you're going to see here today. But actually, before we get into the amazing images, we're going to talk a little bit about where we are. We're standing here outside of the Mission Operations Center, which is the key central hub for Webb. For the past 6 months, scientists and engineers have been working 24/7 since they took control of the telescope 30 minutes after launch to prepare for today and for the amazing science to come. Through all of the major deployments, focusing, aligning the telescope, and calibrating those 4 amazing science instruments, it was all done in this building. And from here on out, we'll have daily communications with the telescope, including sending commands and downloading data with the help of the Deep Space Network. In addition to mission operations, we are also the home of science operations. Well, what does that mean? Every year, we solicit proposals from astronomers across the country and the world for what they would like to look at with Webb. Then we hold a rigorous selection process to select the ideas that will best utilize Webb to study and understand our universe. When the data come down and astronomers analyze their results, we are the lucky ones who get to share that data and those amazing science results with you. And we knew that today was going to be so exciting with the first images, so we've actually been preparing for years. Here is Klaus Pontoppidan, project scientist for Webb and the technical lead for the first images,
it's been a year
to tell you about the process of the past few years of selecting
my first
the
email
targets.
related to the first images was back from 2016. So back then, a committee was created, and this committee was charged with coming up with a long list of targets for the first images. And the reason for that is that the observatory can't see the entire sky at any given time. And this is because you want to avoid the mirror seeing direct sunlight to keep it cold. And it actually had to be a
quiero que confirmen, a ver, ¿me escuchan a mí?
from which we had to select only a handful.
¿Sale el audio?
You know, what would create the most beautiful images, what would highlight the instruments, the different 4 science instruments for Webb, and what would highlight the 4 major science themes for Webb. And it's a celebration as well of the beginning of science observations.
And we knew that selecting the images was just the beginning, that we would need a trained eye to take these exquisite data and pull out the beauty and the science potential. So here's Jody Pasquale and Elisa Pagan to tell you about how they processed these beautiful images.
We're basically translating light that we can't see into light that we can see by applying color like red, green, and blue to the different filters that we have from Webb. And the reason we want to color the images is because there's actually more information that you can get from the image if you see it in color.
So it's a matter of picking and choosing filters and colors.
Gracias. Bueno, tengo que bajarle el audio original porque están poniendo música por detrás. Ayer nos reclamó la Casa Blanca, pusieron música con copyright, son increíbles.
And then we additively combine those together to get our full color image.
But there is a lot involved in this, painstakingly going through and cleaning these images up with an attention to detail, a level of detail like at the pixel level in every image.
So when I'm working on the astronomical data, it is this sort of marriage between
Chica, ¿quién dice que estaba editando?
for the filters. You really are trying to show the different.
No, como qué vuelta que le están dando a esto, la verdad. Me están matando. Genial que le den a la gente. Pum, para arriba. No, Franco es un amigo, Franco Milazzo, que fue que dijo que no salía. Es un amigo. De repente él tiene problemas y no nos escucha. Por eso le hice caso. Es amigo del canal. Lo que pasa es que teóricamente en mi monitor que tengo no está saliendo. No sé por qué. Estoy revisando igual. Sale, sí, sale. Sí, sale perfecto. Sale perfecto. Seguimos esperando, ¿eh?
Specialist. Can you tell us what we're looking at in these images?
So this is a planetary nebula. It's caused by a dying star that has expelled a large fraction of its mass over in successive waves.
Okay, so we actually see those waves in these images.
Yes.
Wow. And so there's a lot of structure. Can you tell us a little more detail about what we're looking? Maybe start with this one on the left.
Yeah. So in the NIRCam image, you see this kind of bubbly, almost foamy appearance throughout the whole nebula with some very structured shells. And this foaminess is showing up in orange mainly. And this is due to the molecular hydrogen that's newly formed.
Sí, una nebulosa.
Just lighting up the gas and dust of this nebula. And then as we move inward, you see this kind of very blue haze in the inner region. And this is actually due to very hot ionized gas.
Eso es hidrógeno, lo azul. Es hidrógeno que está en la nebulosa.
Very hot core of this star.
And what about these like rays
Polvo y
in
gas.
this image?
Right there. So there's also rays in the outer regions that you can kind of see, and these are holes in the inner nebula that are actually allowing the central star's lights to come out and kind of light it up like patchy clouds with the sun shining through.
Wow. Oh, yeah, that's what it looks like. That's so cool. So you're actually a mid-infrared astronomer, which is different than
MIDI.
And so what can you tell us about the details in this
¿Qué
mid-infrared?
podemos de esta imagen?
It looks quite different in color, partly because we're seeing different kinds of physics going on here. So we're actually seeing
Está yendo color porque por la física.
actually due to hydrocarbon grains that are emitting very strongly in the blue from MIRI. And they show the very similar structures to what we see in orange and NIRCam because the molecular hydrocarbon actually forms on the surface of dust grains. And so again, as we move inward, we see that the inner region is again hot ionized gas, but now it glows red because that's where it emits longest for.
Nebulosa del Anillo Sur, nos dice lanzamientos espaciales. 2000 años luz de distancia.
We knew this was a binary star, but we effectively didn't really see much of the actual star.
Habíamos visto ese, pero no podíamos ver la estrella. La vemos. Y ahora vemos las dos estrellas muy claramente. ¡Qué sorpresa! ¿Hay algún huevo de Pascua más?
Up in the top that's radiating
Y vemos un filamento.
Clearly in the MIRI image it shows up as this blue structure, and it points very much to the central sources. So I thought, oh, this must just be a density enhancement in the outer nebula. I thought that very, very strongly, but other people on the team were like, no, it's a background edge-on galaxy. Well, I mean,
¿Eso qué es? Es un reflejo. No, dice, es una galaxia distante.
At both the NIRCam and MIRI images, and it's very clearly an edge-on galaxy with a dust lane and a bulge. So I lost the bet.
Well, you lost the bet, but you got these gorgeous images, so I think it's a win for everybody. Anything else you'd like to say today?
I can't wait to see where we go from here.
Neither can I. All right. Thanks so much. Back to you, Michelle.
Thank you, Alex and Carl. And I have to say that image is absolutely spectacular. So as you know, people from all over the world are watching us today and joining in our excitement as we release Webb's first science images. We've been checking in with our colleagues in Europe and Canada throughout the program, but we also want to take a moment to include the people at the so many viewing parties scattered around the world like stars in the night sky. So let's check in with some of them now. First, we go all the way to Perth, Australia. Do we have a signal from Perth? I guess nothing from Perth right now. Maybe we have some of our other feeds. We're going to check in with them right now. Do we have Winnipeg, Canada? Oh, there it is. There's Australia. There's Perth. Hey, waving to Perth, Australia. Thank you so much for joining us today. And next we're going to Winnipeg, Canada. Hello, Winnipeg. At a planetarium. Everybody's enjoying the show, I hope. Okay, Dayton, Ohio. Everybody's watching on the, there we go, Dayton, Ohio. Hello, everybody, Dayton. Nice to have you here with us. There we go, yes. Hey, hey, Dayton. Hey, they're jumping up and down. Hi. Okay, all the way Bangalore, India. Bangalore. Hello, hello to Bangalore, India. Hey. That's absolutely wonderful. Hey. Okay, so I hope you enjoy the rest of the images we're releasing. Okay, of course, NASA's family extends all over the country. The team at JPL in Pasadena, California, they're on site to celebrate with us. So hello, JPL! Some of my favorite people in the world. Hey, hello! And I think the last place we're going to right now is Northrop Grumman, one of our major contractors. Hello, Northrop Grumman! Oh, hey, all right! Yay! Nice to see you, Northrop Grumman. All right, now there's also a big watch party right here on the NASA Goddard campus. Many of these people have worked on the mission itself, and we also have top NASA leadership and representatives from our government. So hello! Hello, watch party at Goddard. Yay! Okay, wonderful. So, I mean, at NASA, we are so fortunate to have all of these friends and colleagues around the globe. A major partner in the Webb mission is the European Space Agency. ESA contributions have been essential to so many aspects of this project, including Webb's spectacular launch on the Ariane 5 rocket last December. I'm very pleased to turn over the show for a few minutes to Katie Haswell. She's joining me from the European Space Operations Center in Darmstadt, Germany. Hello, Katie. Good afternoon.
Thanks, Michelle. Thank you, Michelle, and welcome to Germany. We're at the European Space Agency.
I'm still getting all kinds of IFB from lots of
center. It's where the teams effectively fly the satellites. They're a little bit of a cross between air traffic controllers and pilots. We have lots of different control rooms here. This is the main control room, and as you can see today, it's not in use, so we've been lucky enough to move in here for today. I have experts with me, both scientists from the European Space Agency. Giovanna Giardino is a near-spec scientist. Giovanna has been working on that for many years. And and Mark McCaughran is a special advisor for science and exploration. These two guys have been working on the Webb space for a long time, so we're very grateful to have you with us. Thanks, folks. We are excited to reveal our image. Before we do that, we thought we'd give you a little bit of background, because we've come here today.
No se escucha la voz, sí, estoy sin voz. La idea justamente, bueno, sí, tengo que bajar el volumen de lo que están hablando. Tengo voz.
They run a system called S-Track, which is NASA's deep space tracking system, and they were listening out when Webb called home. And the controllers here have been looking after a whole very, very impressive list of missions since
Justamente están hablando cómo controlar el telescopio.
ESA has played a very
Lo siento si no escuchan, si no entienden. Estoy sin voz. Estoy difónico. No puedo hablar más que esto. Pero imagino que así me entienden. Y si no, escribo en el chat. Estamos viendo. Están revelando un poco las imágenes.
15 ESA scientists working at Space Telescope in Baltimore, and also they have provided the infrared spectrograph, the near-infrared spectrograph, and also half of the MIRI instrument, which is the mid-infrared instrument. Let's take a look at those now.
Webb's 4 scientific instruments include NIRSPEC, the near-infrared spectrograph led by ESA. NIRSPEC splits near-infrared light from astronomical objects into its components. Like a barcode, this will help scientists understand the physics of the objects they're observing, from their temperature to atomic makeup. NIRSPEC can observe parts of an object or the sky using an image slicer and an array of microscopic shutters. Webb's Integrated Science Instrument Module, located behind the main mirror, also contains MIRI, a mid-infrared camera and spectrograph. Seen here during testing, MIRI's been developed by a partnership between Europe and the US. MIRI detects mid-infrared light from planets, stars and galaxies. It can analyse molecules to help us deduce what astronomical objects are made of and peer into clouds of gas and dust where stars and planets are born. Together, these instruments will help Webb detect and analyse light from the very dawn of time, revealing the universe as never before.
So let's get ready to reveal our image. And remember that one of Webb's jobs is to find out about galaxies, more about the galaxies, but also to help us to understand how they change. And this image is going to
Vamos a entender cómo cambian las galaxias.
Let's reveal it now. There it is. It's called Stefan's Quintet, and it's wondrous.
Stefan Quintet.
Yes, like it's a quintet, so we are looking at 5 galaxies.
Estamos mirando 5 galaxias.
Giant structure that, as we see everywhere around us in the universe. They contain from million to 100 billions of stars, and in fact we live in one of them, the Milky Way.
Millones de estrellas cada una.
This is a closer galaxy in the foreground, and these 4 are at a distance of about 300 million light years from us, and are locked in a close interaction, a sort of cosmic dance driven by the gravitational force. You can see here these 2 in a process of merging
están en el proceso de juntarse, de acoplarse.
Because it really shows the type of interaction that drives the evolution of galaxy. That's the mechanism of galaxies' growth.
César, bueno, es lo que puedo hacer.
Moving through each other. Mark, there's a lot going on though in this image, isn't there?
Marca me dice 300 millones de años entre cada una.
And a mid-infrared image combined. And when we zoom in on the left-hand side here, we see this foreground galaxy. We see lots of individual stars.
¿Quieres salir en audio, Argamis? Te coloco ya.
Which is remarkable. And then as we pan across, we actually see the galaxies in the merging galaxies. We now see gas and dust, which is being heated up in the collision between those galaxies. And that's a place where new stars are being born today. So we're actually seeing the process of creation of new stars in this region. And then when we look in the background here, we see not only the galaxies at 300 million light years, but also stars in our own galaxy. These snowflake structures that you see here, those are nearby stars, but in the corner and around the edges, we see galaxies which are much, much more distant, much further away. So similar in some sense to the ones that we saw earlier on in that deep field. And so this image actually takes us from the nearby galaxy, our own Milky Way, through these galaxies which are evolving today all the way to the distant universe. And in a way, it captures cosmic evolution of galaxies over those 13.8 billion years.
So we have another image, don't we, that we can
Exactly.
look at?
So if we strip away the near-infrared view there of the stars predominantly, now in the mid-infrared with MIRI alone, we see mostly gas and dust. So we see the same galaxies again, the two merging, and then we also see something very interesting up at the top here, because this top galaxy has something new and bright in the middle of it. And Giovanna, tell us what that is.
Yeah, that's an active black hole. We cannot see the black hole itself, but we see the material swirling around, being swallowed by cosmic monsters, and this gas gets heated to extremely high temperature as it falls onto the black hole, and it
Nicolás, Ramón, la próxima está afuera.
the galaxy. Here we see luminosity that are 40 billion times the luminosity of our suns. It's really, really bright. And with NIRSpec, we can zoom into this area, and we have this technology that allows us to take thousands of images at different wavelength channels, so see this distribution of the gas, what's going on in the gas in different regions of this core area, and understand the composition of the gas, the velocities, the temperature. So that's very important to understand the physics.
So it's giving us so much information, and it just shows the power of this telescope. Mark, this is just the beginning, though, isn't it?
I think that's a very important takeaway from today. You know, these are like pictures just taken over a period of 5 days, and every 5 days we're getting more data, which will contribute more in that direction. It's a culmination of decades of work, but it's just the beginning of decades. And you know what we've seen today with these images is essentially that we're ready now. This telescope is working fantastically well, and you know, to borrow a phrase from a famous rock musician, you know, we're ready to turn this telescope up to 11. It really is time. It's fantastic.
Thank you very much indeed, both of you. Back to you, Michelle.
Thanks, Katie. It is so great to have you and your colleagues with us on this historic day. So before we get to the fifth and final image reveal of the day, it cannot be said enough that an achievement like the James Webb Space Telescope is something bigger than any one of us. It's bigger than any organization, any country. This truly takes a planet. Webb belongs to all of us, and starting today, the discoveries start and they're not going to stop. This is just the beginning. We've said several times throughout the broadcast that the Webb mission is about people, and during the construction of the Great Telescope, people started to see themselves in it, literally. Day after day, people visited the observation window at NASA Goddard, and looking through the glass, they snapped selfies of themselves reflected in the gigantic golden mirror. These photos are actual reflections of the enormous human investment and the emotional commitment that brought this mission to life. And now, years later, that mission is finally collecting light from the earliest days of the universe, all the way to worlds in our own solar system. It's the same mirror that reflected the many faces who see themselves as part of the journey to understand our shared origins. Let's stop for a moment and appreciate the people behind Webb. Okay, it's time now for the last image to be revealed. Here we go.
Y terminan porque empieza una teleconferencia de prensa en la que estamos registrados. Vamos a estar en la teleconferencia de prensa,
So Amber Strawn is Webb's deputy project scientist. She's here with me today to share the final big reveal of the day. So Amber, it is so good to see you. How are you feeling?
So great, so exciting.
Está en inglés. ¿Quieren escuchar en inglés a la NASA? Lo pongo. Yo lo estoy escuchando. Pero la idea es que no me tape para poder decir alguna cosa. ¿Quieren el audio en inglés? Lo pongo.
This image really does demonstrate that JWST can do exactly what we've designed it to do.
Yes. And the Canadian Space Agency then took us to the massive planet WASP 96b, where the team has detected evidence of atmospheric water.
And here again, we're seeing the incredible efficiency of this observatory. We're able to do these kind of measurements in a fraction of the time that we were able to before.
And then we zipped up the road from NASA Goddard to the Space Telescope Science Institute, where Alex and Carl showed us the exquisite Southern Ring Nebula, a mixing bowl of stellar matter.
Muestran la última y suben, Karina.
Yeah, and I'm just blown
Hoy
away
está
with the
Karina.
level of detail we can see, like in the outer part of this nebula. It's incredible.
Wow. Okay. After that, it was off to Germany, where the European Space Agency wowed us with pictures of galaxies interacting and mixing together.
Right, and this image, again, it's incredible because it's showing us one of these fundamental processes of the universe, how galaxies merge together, and we're able to learn about these processes in a brand new way.
So the Webb team has a lot to cheer about right now. So across the campus, there's this big watch party, and we can feel the excitement all the way from over here. So let's join that celebration now. We're back with Senior Project Scientist John Mather, along with the head of NASA's Science Mission Directorate, Thomas Zurbuchen. Hello.
So, John, we looked around the world and we're the only ones with a cheerleading crew right over there. That's amazing. Look, you've been with this mission for decades. How do you feel today?
I am so thrilled and so relieved. This was so hard, and it took so long. It's just impossible to convey how hard it really was. That we risked so much to say we're going to go do this, and it's so near impossible, but we did it.
Yeah, there are thousands of ways this can go wrong.
Yes.
Many of them, we
Miles de cosas podían salir mal.
feared even after launch. I have to tell you, I was really, really nervous, and it's almost like athletics for me. You always get to know the team when they're on the field.
Lo que está demorando en descargar esto es brutal.
Right after this launch, and they were perfect.
They absolutely were. And I wasn't worried, but maybe I should have been.
Yeah, that's difference between the two of us. I always worry. I always tell everybody I'm paid to worry, frankly, and that's good. What we want to do, though, is just really thank the team again. Of course, we heard Bill and Scott and Greg talking about the team that is there. I think what's also important is to recognize that Bernie is sitting there. He was the first manager. I was sitting there. Could you stand up? And I want to mention that Phil Sabelhaus, who was a manager also during that time, is no longer with us, but his heart is with us today.
Yeah.
I have to tell you, John, after each one of these milestones, I called a lot of people. I called Bernie, for example, and I called people who had my job and people who are administrators, because there's many of them. And I just wonder how you feel about the team. Just give you the word here.
I am just so thrilled that we had a privilege to assemble such a brilliant team. We drew from the best of the best, and here we are. So my extreme
Tuve el privilegio de poder elegir a la gente y lo conozco a todos.
to Bernie, who started us and helped us build up all the technology, to Phil, who made sure we would have a plan.
No hay nada relevante, no. Están haciendo un show. Thomas Zurbuchen es el capo de ciencia y está junto con el investigador principal.
We have the support of the country and the world to take on this immense challenge.
You know what I'm most excited about? There's tens of thousands of scientists, and frankly, some of them just got born or not even born, who are benefiting from this amazing telescope, because it will be with us for decades.
It will be. It took us about 25 years to get here, since 1995, and we have at least 25 to go, I hope.
So look, we are in a sense of these images, the art that is out there in the sky, revealed for the first time. We're thinking of the team and we're thanking them. John, thanks to you, thanks to all of you, and back to Michelle.
Thank you so much, Thomas. And this entire collection continues to just absolutely astound me. Okay, Amber, so here it is. Can you walk us through the final image reveal?
Imagen final. Parece que ahora es fin.
Here we go.
Imagen final. Ahora sí.
The last image is, wow, look at that. So, Amber, can you tell us a bit about what we're seeing here?
Of course. This stunning vista of the cosmic cliffs of the Carina Nebula.
Karina.
New details about
Karina.
Today, for the first time, we're seeing brand new stars that were previously completely hidden from our view.
There's something you want to point out here?
Absolutely. So, honestly, it took me a while to even figure out what to call out in the image.
Lo digo nuevo.
So much going on.
Karina.
So beautiful. One thing that really stands out to me is you sort of get this sense of depth and texture from this new data. There's a lot going on. To call out a few specifics, first of all, in general, the Carina Nebula is a nearby star-forming region within the Milky Way galaxy, about 7,600 light years away. And in this view, we see some great examples, first of all, of hundreds of new stars that we've never seen before. We see examples of bubbles and cavities and jets that are being blown out by these newborn stars. We even see some galaxies sort of lurking in the background up here. We see examples of structures that, honestly, we don't even know what they are. Like, what's going on here? The data is just so rich.
And there's something really special about the infrared. Infrared can actually see deeper into these star-forming regions.
Absolutely. That's one of the great things about infrared, is it really does reveal what's going on here in a really cosmic sense. And in general, what's happening in sort of this overall landscape is we have these gigantic, hot, young stars up here to the top of this rim, and the radiation and stellar winds from those stars is sort of pushing down and running into all of this. This is gas and dust. And of course, we know that gas and dust is great raw material for newborn stars and baby planets. But there's also a little bit of a mystery. To sort of erode away this material and stop star formation. So we have
se empiezan a formar las estrellas con esto.
New stars being formed, but at the same time, the star formation is being halted. And for me, when I see an image like this, I can't help but think about scale. You know, every dot of light we see here is an individual star, not unlike our sun, and many of these likely also have planets. And it just reminds me that, you know, our sun and our planets, and ultimately us, were formed out of the same kind of stuff that we see here. We humans really are connected to the universe. We're made of the same stuff in this beautiful landscape.
And actually, the Carina Nebula was one of my favorite images from Hubble, so Hubble looked at this as well.
Solo para que vean la definición que tienen las fotos que ya se pueden bajar.
Spectacular. We saw it in a different kind of light when Hubble took an image of this particular nebula. And then you can see amazing things with Hubble, but when we zoom into this new image, we're able to see so much more detail. And of course, all of us, you know, I and all of us love Hubble, and I'm so excited to see what these two amazing observatories are able to do really in tandem with each other.
Thank you so much. And again, congratulations. It's been a pleasure to be working on this with you. I'm just amazed by what's been going on.
I am too. Thank you.
So as we're wrapping up, one of the things that I really have to say is the journey that we've been going on is so very dramatic for me. So we've gone all the way from the birth of stars, and we have all the way from the distant galaxies to the birth of stars. This is where we all began. This was the whole point of the James Webb Space Telescope, to figure out our early days of the universe, to star and planet formation very nearby. So right now, I'm very honored to have our last special guest. This is the administrator of NASA, Bill Nelson. An honor to be with you, sir.
Hey, what a pleasure. What a banner day.
El administrador de NASA. Qué increíble. Increíble. Bueno, se viene la conferencia de prensa, Se viene la conferencia de prensa que vamos a estar transmitiendo. Voy a loguearme con ellos mientras esto termina. Recuerde que están todas las imágenes para descargar. Vale la pena mirar punto a punto. La resolución es impresionante.
Something incredible is waiting to be known. I think those words.
Dijo la palabra de Carl Sagan. En algún lado siempre hay alguien esperando que venga.
Wow. So this is a celebration for all humanity. If you've ever looked up at the night sky and wonder, whoever you are, wherever you are, this is your telescope. And we also salute the thousands of people who have dedicated part of their lives to making Webb a reality. I also want to give a big shout out for the superb media bring Webb story to the world.
Así que bueno, esto habrá sido todo, pero seguimos con la conferencia de prensa. No se vayan. seguimos. Es dentro de una hora. Lo pusieron en una hora. Nos vemos ahora enseguida, ¿no? Dentro de una hora. En una hora. Gracias. A ver, nos vemos en una hora. No sé si salió porque estaba la música y mi voz no sale casi. Así que gracias a todos. Coti, teletranspórtame. Chau. Chao.